Hi students, welcome to DMT Chemistry World. No, I'm not seeing any question mark on your face, but I can see some curiosity on your face. Hi students, all of you ready with your pen and book? Yes, let us begin the third class. So before you have to start the third class, let us recall the second video what you discussed. Yes, in second video we discussed about the classification of matter on the basis of the physical states of matter. On the basis of the arrangement of the molecules, the solids and liquids and gases are the three states of matter we classify. So we can define these three states only by using three terms. One is a shape, a mass and volume. Yes, in solid, all the three are fixed. Mass is fixed, shape is fixed and volume is fixed. Whereas in case of liquids, out of these three, only two are fixed. Which are the two are fixed? Yes. So liquids have definite mass and definite volume, but no definite what? The shape. Whereas in case of gases, out of these three, only one is fixed. Which is that? Yes, in gas have definite mass, but no definite shape and definite volume. So now let us continue the class with the characteristic of the three states of matter. Yes. Characteristics of states of matter. Okay, I am going to draw a yes. If you consider arrangement of particles, if you take now, this is what? Yes, systematic, closely the packed. Yes, it is solids. In case of liquid, the molecules are loosely packed. This is what? Liquids. In case of gas, the particles are free to move. Yes. Now if you have to compare the three states of matter with respect to arrangement of particles, so because of closely packed, here the particles are not moving, as if in the students in the presence of class teacher. So they are not moving. Like here also, these particles are not moving. Just they vibrate from their position like this. If it's a particle, it vibrates from their position. That means they are vibrating here. They are vibrating. But in case of liquids, because they are loosely packed, and there is, they are moving from one apart another. These molecules move this, and this molecule moves here, and this molecules move here. So like this, here the molecules are move apart to one another. So how I told, this is the class in the absence of teacher, how the students will move from one place to another place within the classroom. So that in the liquids, within the liquids, that particles are moving. So this is called what? They move upon one another. Yeah. But in case of gas, see, what is there? Here the gases have no any binding force, no, and they are free to move in any direction. I told this is the like how the students are outside the classroom. So there was see there is no restriction for them. They haphazardly they're moving one by move this side, one girl move this side. So they're moving haphazardly. So similarly here gas molecules are what? They have what? Haphazardly movement. Moving with great speed. Moving with what? Great speed. So this is how we can say a first characteristic about their movement. They are vibrating in their position, they are moving upon one another, and they move with a great speed with haphazardly. Okay. So next we shall come here. So because of here the particles are very closely arranged, so there is some kind of force of attraction. So between the molecules there is a force of attraction. So this force of attraction is called intermolecular force. Inter means between. Between a molecule some force of attraction. That is called intermolecular force of attraction. So because they are very closely packed, so here what? They have strong force is what? Strong intermolecular force. Strong intermolecular force. Where in case of solids there is a strong intermolecular force. As if you see the students are sitting in the classroom in the presence of a teacher, so they are just sit in a systematic manner with touching with each other. The students are touching with each other in the row. That means they are some force of attraction. That is so strong intermolecular force. So in the case of what? Solids. If you take the liquids, so because the molecules are not so tightly packed, so because the force is there but not so strong, it has a what? The weak force. Is a what? Weak intermolecular force. Is a what? Weak intermolecular force. Means the force is not much stronger like the solids. It is a weak intermolecular force. Because of that only they move upon one another. Okay. But in case of gas, so there is the molecules are lie apart. They far away, not so close. Hence, what? No intermoleculars. What? No intermolecular what? Force. There is no force of attraction between the molecules. Almost it is absent. It is absent. If you come to the third point, okay. Now what is the third point? If you take third point in solids, okay. What is third point? So in solids, so between the molecules there is no space. That is the space between the molecules is called intermolecular space. So between the what? These molecules there is no space. So there is no what? Intermolecular space, almost absent. In what? In solids, intermolecular space means no intermolecular, no intermolecular space. Okay, so shall I repeat now? I will write here the vibrating board what I can say that the third point is no intermolecular what? Space. There is no space between the molecules. Whereas here a small space is there between one molecule to another molecule. There is a small space. That means see, less intermolecular space. You can say what you can call it as what? The intermolecular space is what? There is a less intermolecular space. Less intermolecular space. There is a less intermolecular space. Where in case of the liquids, whereas in case of the gas, how this space, see, this space is very less here. This is called what? intermolecular space in what? The liquids. But this space between the molecules, the space is very large. It's a large intermolecular space between the molecule. This is called intermolecular space. How it is there? It is a large intermolecular part space. See, in solids, no intermolecular space because they are very close. There is no space between molecules. In liquids, they are loosely packed. So little the space is there, that is gap is there, that is a little gap, that is less intermolecular what? Space. Space. So here there is a large intermolecular space. I come to this. Here then we can come, that is called the fourth point, kinetic energy. Kinetic energy of particles. So what is kinetic energy means? If moving object has energy called what? Kinetic energy. Energy of a particle due to its movement, that is called what? Kinetic energy. If movement is fast, more kinetic energy. If movement is less, what? Less kinetic energy. So here in case of solids, they are not moving, hence they have what? Least kinetic energy. The kinetic energy is what? Least in case of solids because the particles are not moving, just they vibrate from their position like this. But here in case of the what? Liquids, the kinetic energy is what? Less, not much. Kinetic energy because the particles are moving with less speed. Hence there the kinetic energy is what? Less. But in case of gas, the kinetic energy is very high. Why means here the particles are moving with great speed because of what? They have high kinetic energy. Because of the high kinetic or very high kinetic energy, the particles are moving. In case of solids, the kinetic energy is least, and in case of liquids, it is less, not S. Whereas in case of gas, it is very high. This is the fourth characteristic. Now, the fifth characteristic we have. So, what is the fifth characteristic? Yes, now we can come to the fifth characteristic called, yes, I will going to rub it. The fifth characteristic is called, we can call it what? Compressibility. What is called? Compressibility. So what is called compressibility means, so just you take, so bringing the molecules from closer to close, bringing closer to each other, bringing the molecules nearer by applying some force. So by using some force. So that is called what? Compressibility. What is called? That is compressibility. So to bring the molecules from closer, there should be space. When there is a space, only we can bring what? Closer. But here there is no space. Already they are very tightly closed or closely packed. Here no space to bring them. Hence, see, you can say in solids there is no possibility of compressibility. You cannot compress the solids. Cannot compress the solids. If you take now, you can compress, no. So because the particles are closely packed, so there is no what? Space to move. So there is no what? Space to move the particles. Hence what? Hence solids compressibility what? They are non-compressible. Solids are what? Non-compressible. Whereas in case of liquids, we can see the space is there. In liquids, just to apply some force or pressure, we can bring these molecules a little closer. That means they are less compressible. What is in liquids? These are less what? Compressible. These are less compressible. In case of gas, how they are? See, large intermolecular space is there. Because of this large intermolecular space, we can bring these molecules closer, very close to each other, or bring nearer to each other by applying some force. Hence, we can highly compressible. What? These are highly compressible. It is the very important property of what? The gas. Because of this compression property is used in our daily life. So we'll discuss in the next class how using these properties is. So what is compressibility? So bringing the molecules of matter nearer to each other by applying some force is called compressibility. The solids are non-compressible, liquids are less compressible, gases are highly compressible. So this is the fifth property. The last property or characteristic is we have, that is called diffusion. Diffusion means if you bring two gases which are not chemically react, so these two gases are intermixed with each other. That means, they mix with each other means the one molecules go and just take the position of intramolecular space of other molecules, and this molecule of other gas go and take the position of intramolecular space of the other gas. So this intermixing of two gases which are not chemically react are called what? Diffusion. What is diffusion? Intermixing of two gases. Intermixing of two non-reacting gases. They should not chemically react. Reacting gases is called what? Diffusion. Actually, this is the characteristic of gas. See, solids non-diffusible. Why means? Again, see here the particles of gas or the molecules of gas mix with the intramolecular space of other gas. So the space should be required to mix to take the position of the intramolecular space. In solids, no intramolecular space, hence what solids are non-diffusible. Means they are not diffusers. You bring one solid contact with the other, suppose. So does these two. Suppose this is a tester and this is the water. This. Yes, this tester is made up of some molecules. What is this? So plastic is made up of some molecules. If you bring contact with each other, so they will not take they will not intermix because there is no intramolecular space. Yes, they are non-diffusible. But liquids. So liquids are less diffusible. You can see that. What is? Liquids are less diffusible. Why means? If you take a ink, put a drop of ink in the water, you can say ink diffuses in water. That means the ink particle take the position of or occupy the intermolecular space of the liquid water. Hence, you can say they are less diffusible. These are what? Less diffusible. Yes, these are less diffusible. Whereas in case of the what? The gas, because of what? This is a very, very large intermolecular space. Hence, this space occupied by other molecule of gas, so that they intermix with each other. Hence, they are what? Highly diffusible. Highly diffusible. See, what is diffusion? You know already. See, solids are non-diffusible, so liquids are less diffusible. Gases are highly diffusible. What is diffusion? So diffusion is the property of what? The gas. So actually intermixing of two non-reacting gas. Two non-reacting gas. Gas should not be chemically. is called what? Diffusion. Is called what? Diffusion. So for example, I will draw one diagram. Okay, now I am taking, this is how a two yes, it is a two bulb. One is filled with some gas like oxygen gas. Yes, what gas this is? Oxygen gas in a container, and in that some have some other gas like okay, there's some other gas like nitrogen dioxide. See, it seems I'm letting some thick, so this is some other gas. So this is what gas A contain what? This is oxygen, and this is what? Some gas like nitrogen dioxide. These are the gases. So these are not, these are controlled by a tap here. Some tap is there. So it will what? This. Now these are oxygen and nitrogen dioxide are filled in separate the bulb. Okay. So they are not allowed to mix because they are, this tap is there. Now when tap is open, what happens? When tap is opened, this is opened. What happens? Tell me now. Yes, what happens? So this is how. So this is first one. Okay. This is what? Second. This is A and this is B. Now as soon as you open these particles, these gas molecules of nitrogen dioxide, what is this? Nitrogen dioxide. These will move towards this gas and they take the position of intermolecular. They occupy this position, and these will move here and they take the position. That means, suppose if you take here, this is what light. I picture light means what this is. Now here these are what? The particles of what? The gas molecules of what? Nitrogen dioxide. Here also we have this bright means they are gas molecules of nitrogen dioxide. Here what? Yes. And like that we will get, this is how. This is called what? Diffusion. When two gases like which are not reacting, they bring contact with each other. So the one gas molecule occupy the intermolecular space of other, and this gas molecule occupy the intermolecule. You can get a homogeneous mixture of two gases. So this is called what? Diffusion, and this is an important characteristic. Diffusion is a what? An important characteristic of what actually? Gases. Gases are highly diffusible. Let us discuss this application in the next class. Okay, students, now I will give a chart. To complete the chart as a homework, you just complete it, and if any doubts, you just comment me in the comment box, and I will answer. Okay. Yes. Now this is the yes. Here I will write this characteristics properties. Here states of matter, I will write here. One is solids, other is what? Liquids. So next is what? Again. Okay. Now you should fill up this part. There. First is, yes, first is what? Shape. Should write for solids. Second is what? Mass. Third is what? Volume. Should write. Okay, you should write, right? Next is what? Arrangement of molecules. Next is what? Movement of movement of molecules. So next is what? Kinetic energy of molecules. So like this you fill it. How? What is the shape, liquids and gas? So you just fill it, and this is homework for you. Okay, you just take it and fill it. Like this, remaining characteristic we'll discuss in the next class. If any doubts, please comment me in the comment box. Okay, students, let us finish this today class. Let us stop today class. We'll continue in the next class. Till that, we just take rest and enjoy. And before that, we recall the first, second, and third videos. Okay.